Hello, 8th graders. This is our last unit on the radicals. We're going to be focusing on Pythagorean theorem in real life situations. So we're going to get the story. We're going to try to figure out where the triangle is. We're going to draw it, label it, solve it, and then when we're at the end, we're going to work with the square root like we've been doing in this unit. A wheelchair ramp is needed at the entrance to a building. The ramp is needed to climb a height of 3 feet. There is only 10 feet of space available for the ramp. How long should the ramp be? So first off, let's see our triangle. So we've got the triangle right there. We know that it needs to climb up 3 feet, so that is our height. There's only 10 feet of space available, so that is the ground space, and we'd like to know how long the ramp is going to be. Our next step is to label with A, B, C. So it works best if we do A as the smallest, B as the middle, and C as the hypotenuse, the longest side across from the right angle. We remember our Pythagorean theorem is A squared plus B squared equals C squared. We're going to plug in our numbers. So instead of A, I'm plugging in a 3. Instead of B, I'm plugging in a 10. Our next step is to do those. That's 3 times 3 and 10 times 10. They are on the same side with a plus sign, so I'm going to go ahead and add them. So that's 109 is C squared, but I don't want to know what C squared is. I want to know what C is. So to solve anything here, we do the opposite, and the opposite of the square is the square root. And when I do it to one side, I'm going to do it to both sides. So C is the square root of 109. So first off, the 109 is not perfect. So the next thing to consider is, do any of the perfect squares divide into it? And just a quick glance at it kind of makes me feel like it's prime. I don't think any of our main ones, none of the even ones definitely, not the 5s. I can do my 3 trick and see that 3 doesn't go into it. So I am going to declare that done and leave that right there, square root of 109. During a baseball game, the second baseman gets the ball and throws it to the catcher to stop a runner before he gets to home. If it's 90 feet between each base, how far did the second baseman throw? So here's second base, and they threw there, and there's our triangle, and this is the right angle there, the baseball diamond. I don't think I have to turn it. Let's leave it the way it was. So I know that it's 90 feet between home and first, and between first and second, and I'd like to know how far it is from second to home plate. So here is A, B, and C. Pythagorean theorem, A squared plus B squared equals C squared. Plugging in my numbers. Now this one's going to get pretty big with those 90s, but nicely it's just going to be a lot of zeros. So 90 times 90 would be 8,100. And we got 2 of those. We're going to add those together. Equals C squared. Opposite of squared is the square root. And I'm going to check that out and see if the square root of 16,200 works out. Nope, not exactly. So we could definitely get 100 out of that. Well, let's see if we can get something bigger. Yep, so let's do, oh, well, that makes sense. 8,100. 1 second, please. Square root of 8,100 is 90. So we're going to do 8,100 times 2. The 8,100 is going to come back out as the 90. So my simplified answer is going to be 90 square root of 2. A water park wants to add a zip line into a pool. If the platform at the top of the zip line is 25 feet tall and the pool is 40 feet long, what is the maximum length needed for the zip line? Actually, we should probably say the minimum, because it would be good to have a little bit extra on the zip line. So here we have our A, our B, and we're looking for C. Going into a squared plus b squared equals c squared. Putting in our numbers, 25, 40. Again, these are going to get pretty big. Certainly feel free to use your calculator on this. 25 times 25 is 625. 40 is 1600. They are on the same side, so I'm going to add those two together. That gets me 2225. Opposite of square is square root. I do that on both sides. So I would like to know the square root of 2225. Doesn't work out. So instead I'm going to see if any perfect squares go into it. And it is 25 times, looking at my calculator here, it's 25 times 89. So where can we do this? I guess we'll squeeze it in down here. Square root of 25 is 5, and the 89 is going to stay inside there. So 5 radical 89. Now that is certainly not a number you'd go to like Home Depot and say, I want 5 and square root of 89 worth of zipline. You'd calculate it out, but to have a precise answer, we leave it this way in our math class. And lastly, a kite at the end of a 40-foot line is 10 feet behind the runner. How high is the kite? So this is going to be our triangle. We know that it is a 40, at the end of a 40-foot line, it is 10 feet behind, and we'd like to know how high. So this is our first variation on that problem. In this case, we do have the C, and we're going to be looking for the B. So I've got a squared plus b squared equals c squared. I'm putting in my a. I'm looking for my b, so that's going to stay. I've got my c. 10 times 10 is 100. 40 times 40 is 1600. Okay, so now this one is different. They're not on the same side with the plus sign, so I'm going to do the opposite of that plus, which is minusing. So I'm going to minus on both sides. So b squared is 1500. I'm going to do the opposite of the square, which is the square root. And I'm going to look at what goes into 1500. So that is 100 times 15. What makes 100 is 10 times 10, and the 15 can stay right there. So our final answer is 10 radical 15. Now this homework is slightly out of order. This is homework 7.2. But this will be our last one in this unit, and the next unit we'll be working on a little bit of algebra that you will definitely need to get before you can succeed in high school there.